A mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen.
August 6, 2025. NASA made a choice that stunned the scientific world. The James Webb Space Telescope, built to study the first galaxies and search for alien worlds, was suddenly forced to shut down its main mission. Webb was never meant to chase interstellar visitors, yet one object left NASA with no other option. That object was 3I Atlas. At first, it looked like nothing more than a wandering comet, but then it began to send signals that shattered every expectation. Something in its light, its motion, and its chemistry was so strange that NASA risked years of research to track it. So what exactly did 3I Atlas reveal, and why was NASA compelled to rewrite Webb's mission for this one visitor? The James Webb Space Telescope was built to study galaxies, stars, and planets billions of light-years away, not to chase comets rushing through our solar system. Its schedule is planned months in advance, with every observation carefully debated and balanced against fuel costs and scientific priorities. Changing that schedule is like rewriting the rules of a massive orchestra. Yet on August 6, 2025, Webb broke from tradition. For the first time since launch, its controllers ordered a full emergency override to capture a single moving target, the mysterious interstellar object known as 3I Atlas. Normally, any change in Webb's observation plan must pass through committees of scientists who weigh the risks against the benefits. This process can take weeks or even months. But with 3I Atlas, there was no time for debate. Ground-based telescopes in Hawaii and Chile had already reported that the object was accelerating in strange ways. Its light was flashing with metals that did not belong in a normal comet, and its trajectory was shifting hour by hour. If Webb did not turn its sensors immediately, the chance to study it could vanish forever. The override chain went all the way up to the project's lead scientists, and their decision was unanimous. They would risk Webb's precious schedule for this single shot. The danger of such a move was real. Webb's instruments are delicate, and every change of direction costs fuel, which cannot be replaced. A single error could lose days of science, or in the worst case, damage a system that has to survive for decades in deep space. But the team agreed that 3I Atlas was too unusual to ignore. At 2:17 GMT, the command was uploaded. Webb pivoted, its mirrors humming as they lined up with new coordinates, while every eye in the control room locked on the telemetry stream. The first images that came down were rough, uncalibrated frames, but even they told a shocking story. Against the black backdrop of space, the comet's core glowed far brighter than expected. Within minutes, the spectrograph began sending lines of data that confirmed what the ground telescopes had seen. Carbon dioxide dominated the spectrum in amounts never recorded before. The tail stretched unnaturally thin, almost ghost-like, while nickel lines appeared with a clarity that erased any doubt. The atmosphere in the control room turned from excitement to stunned silence. The override had paid off, and the risk had uncovered something no one had imagined. Fewer than 5 emergency overrides have ever happened in Webb's history, and none of them were for an interstellar object. This one set a precedent. It showed that even the most carefully planned mission could bend when the universe throws a puzzle at our doorstep. The override was not simply a technical decision, it was a signal that the rules of space science had shifted. The comet was rewriting the script, and the world's most powerful telescope had been forced to follow. The question now was clear. What kind of comet forces humanity's greatest observatory to abandon its normal mission? When Webb's spectrograph first locked onto 3I Atlas, the team expected to see water vapor rising gently from the frozen body. That is the usual pattern in comets. Water ice begins to boil off when sunlight grows strong, creating a bright coma and a dusty tail. But the numbers flashing across the monitors told a very different story. Water was there, but only in small traces. The dominant gas, the one pouring into space in huge amounts, was carbon dioxide. The ratio was 8 parts carbon dioxide to 1 part water, the highest ever measured in any comet. For comparison, most solar system comets show less than 1 part CO2 for every part of water, and even the interstellar visitor Borisov stayed close to that norm. 3I Atlas was breaking away from everything known. What made this finding even more shocking was the distance from the Sun. At over 6 astronomical units far beyond Jupiter, the faint warmth of sunlight should not have been enough to wake a comet. Normally, comets remain quiet in such cold regions, only becoming active when they move closer to the inner planets. Yet 3I Atlas was already venting enormous clouds of gas, producing a tail that stretched hundreds of thousands of miles. To the scientists watching live, it was as if the object had an engine inside, turning on far too early and in a way that did not fit any natural model. The appearance of the tail was just as strange as the chemistry. Instead of the bright, dusty plume common to comets like Halley, the tail of 3I Atlas looked ghostly and thin. Dust, which usually gives a comet its glowing white or yellow streak, was almost absent. What remained was a transparent stream, driven mostly by invisible molecules of gas. In photographs, the tail looked less like a streak of light and more like a shadow stretched across space. For experienced astronomers, this was deeply unsettling. It meant the comet was not shedding rock and ice in the usual way, but was dominated by a chemical reaction that no one had expected. Some experts suggested that 3I Atlas must have formed in an environment very different from our solar system, perhaps in a region of a distant star system where water was scarce but carbon dioxide was abundant. Others propose that the parent body may have been rich in unusual ices, combinations of carbon and oxygen that remained trapped until a sudden release. Still, no model could explain why the gas appeared in such vast quantities or why it erupted so far from the Sun. Every possibility pointed to a birthplace or a process unfamiliar to Earth-based science. The numbers did not only challenge comet theory, they raised a much larger question. If 3I Atlas carried chemistry unlike anything in our solar system, then what does that say about the diversity of worlds beyond our own? And if a comet can break the rules of physics so early in its journey, what other surprises might be waiting as it travels closer? If the chemistry of 3I Atlas had already shocked astronomers, the discovery of its metals was even more unsettling. When Webb spectrograph scanned deeper into the light of the comet, it revealed strong, clear lines of nickel. The surprise was not that nickel was present, since small amounts are normal in comets and meteorites. The true shock was the complete absence of iron. For every comet ever studied in our solar system, nickel always travels with iron, bound together in cosmic dust. Here, nickel outnumbered iron by more than 40-1, a ratio that broke every rule of planetary science. In the laboratory, separating nickel from iron is no simple task. Industrial processes on Earth use high heat, chemical baths, and precise methods to refine metals. To see this separation naturally in space seemed almost impossible. Astronomers compared the readings against every possible source of error. They checked the background light of the stars, searched for contamination, and recalibrated Webb's instruments. Other observatories joined in, including the Very Large Telescope in Chile, yet the results matched. Nickel was there in staggering amounts and iron was missing. The numbers were not small fluctuations, but consistent, undeniable data. The mystery deepened when scientists considered the possible chemistry behind it. One idea involved nickel carbonyl, a molecule that can form when nickel bonds with carbon monoxide. This compound is highly volatile and can vaporize at temperatures around 43 degrees Celsius, releasing nickel into space. Its cousin, iron carbonyl, behaves very differently. It is less volatile, slower to form, and unlikely to survive in a comet's icy shell. This chemical path could explain why nickel appeared without iron, but only if the parent body of 3I Atlas formed in a unique environment where nickel was favored over iron. Such a birthplace would be unlike anything seen in our solar system. The implications are enormous. If the absence of iron is real, then 3I Atlas may be the fingerprint of a distant star system where planetary chemistry followed a different path. It could point to a world where metals condensed under exotic conditions, or even to processes not yet understood by modern science. For researchers, the finding was like discovering a gold ring without any trace of silver or copper, an object that simply should not exist. The more they examined the data, the more it looked like the comet carried a signature of deliberate separation, something that nature rarely performs on its own. Such anomalies push the boundaries of what astronomers can explain. Was this just an extreme example of unusual chemistry, or could it be evidence of something more? The puzzle of nickel without iron not only challenges our models of comet formation, but also raises the unsettling question of whether 3I Atlas could be more than just a natural fragment of ice and rock. And if this is the case, what kind of force or intelligence might be behind it? The chemistry of 3I Atlas was already strange, but its movement through space became the detail that truly unsettled astronomers. When tracking teams compared its orbit to the pull of gravity, the numbers broke apart. In only 72 hours, the object's velocity increased by 0.12 meters per second squared. For a body almost 7 miles wide, such an acceleration is not something nature produces easily. It was compared to a cruise ship suddenly gaining speed on calm waters without engines or sails. Every observatory, from Pan-STARRS to Gemini South, confirmed the measurements, leaving no room for mistakes in calculation. The acceleration curve was not smooth. Instead, it showed a series of sharp jolts stacked on top of the main path. The comet did not drift along a graceful arc. It twitched, shifted, and then stabilized again. These flickers were not random outbursts of gas. On normal comets, jets of vapor appear and vanish chaotically, but over time their influence averages into predictable trends. With 3I Atlas, the spikes repeated in a way that looked intentional, as if timed by a hidden system. The data suggested a rhythm, almost mechanical, which is not something usually associated with natural bodies. Light measurements made the case even stranger. Photometric observations showed a clear brightening every 7.2 hours, repeating with machine-like precision. A natural comet, if it were tumbling, would display irregular flashes that change as the object spins or releases gas. But here, the brightening remained locked to the same period, no matter how much activity increased. If 3I Atlas were freely rotating, the loss of material should have slowed its spin. Instead, it maintained the exact rhythm, like a metronome keeping perfect time while the world around it shifted. For many astronomers, this was the most disturbing sign of all. Theories began to multiply. Some suggested that the object might have a large flat surface reflecting sunlight, acting like a rotating sheet. Others tried computer simulations, modeling hollow shapes or unusual geometries that might explain the pattern. None of these models could replicate the sharp regularity of the observed cycles. The precision was too clean, too exact, to be explained by random geometry. The comparison to a lighthouse beam sweeping the sky became common in discussions, a metaphor that captured the eerie consistency of the light curve. Veteran scientists immediately recalled Oumuamua, the first interstellar visitor discovered in 2017. That object had also accelerated in a way gravity alone could not explain, sparking debates that continue to this day. Yet 3I Atlas was not only brighter, but also more regular in its signals. Where Oumuamua left open space for natural explanations, this new arrival seemed to erase them one by one. The similarities between the two objects gave weight to the suspicion that humanity might be seeing patterns not produced by random cosmic chance. The evidence forced a chilling possibility. If a comet can accelerate in bursts and shine with such steady rhythm, then perhaps it is not a comet at all. Was this a case of extreme outgassing never seen before, or was it proof of something built rather than born? And if the latter, then what kind of intelligence or unknown force was guiding it through the darkness? Long before modern science explained the behavior of comets and asteroids, ancient people looked to the sky for signs. They did not have spectrographs or telescopes, but they left stories, artifacts, and warnings that still echo today. One of the clearest clues is found in Egypt, where small beads discovered in tombs dating back to 3200 BCE carried a hidden message. They looked like ordinary decorations, rolled into tubes and placed among grave goods. Yet chemical tests thousands of years later revealed they contained almost 1/3 nickel. Such a high level was impossible to achieve with the primitive smelting techniques of the time. The only source was meteorites, which fell to Earth, carrying the chemical fingerprints of space. To the Egyptians, this strange metal was literally iron from heaven. The fascination with sky-born metal did not stop there. The most famous example is the dagger buried with Pharaoh Tutankhamun, a blade that has survived more than 3,000 years without rusting. When analyzed by X-ray fluorescence, the weapon showed about 11% nickel and traces of cobalt, perfectly matching the composition of iron meteorites. For the Egyptians, such a blade must have seemed divine, a weapon forged not by earthly fire, but by the fall of a star. Modern scholars see it as proof that humanity has always been shaped by what arrives from beyond, even when people did not fully understand it. Mesopotamian cultures carried the same sense of awe and fear. Clay tablets from Babylon describe stones that rained from the sky, linking these events to the fates of kings. The Akkadian word anbar was used to describe sky metal, and it appeared in lists alongside silver and gold, marking it as a rare and powerful substance. Ritual texts warned rulers that fire from the heavens could signal war or disaster. To them, iron falling from above was not only a resource, but also an omen, a reminder that cosmic forces could overturn the order of their world. Historians have traced these traditions across cultures. In Anatolia, early smiths prized meteoritic iron, using it to craft ceremonial weapons. In China, ancient records mention heavenly stones that changed dynasties. The pattern is consistent. Whenever unusual metals arrived from the sky, societies treated them as both gifts and threats. These materials were worked into beads, blades, and amulets, but they also carried a shadow of warning. The Widmanstätten patterns inside meteorite iron, visible today under microscopes, confirm their extraterrestrial origin. Ancient people could not see those structures, yet they sensed that such matter was not of Earth. This history now feels uncomfortably close to the mystery of 3I Atlas. Just as ancient cultures saw meaning in sky iron, we now face an object delivering a chemical fingerprint that no comet should have. Nickel without iron, rhythms without natural cause, and signals that resist explanation. If our ancestors once feared that strange metals foretold upheaval, what should we think when the sky itself presents us with a riddle science cannot yet solve? As the data on 3I Atlas spread through the global scientific community, the response was anything but united. On one side, a group of respected astronomers argued that the comet was simply extreme, but still natural. They suggested that its strange chemistry could be explained by a rare birth environment, perhaps in a carbon-rich nebula where iron stayed locked in minerals while nickel formed volatile compounds. Others proposed exotic models of outgassing, claiming that carbon dioxide jets could mimic some of the acceleration spikes seen in the data. For them, the object was unusual but not impossible. However, another group was far less convinced. Among them was Avi Loeb, the Harvard astrophysicist already known for suggesting that Oumuamua might have been artificial. Loeb wrote bluntly that separating nickel from iron in space would require conditions beyond anything currently known. In laboratories, it takes advanced industry to achieve such ratios, so finding it naturally seemed almost absurd. He pointed to the repeating light curve and the sharp acceleration jumps, describing them as features that fit a machine far better than a comet. His words sparked fierce debate, as some dismissed his claims while others quietly admitted that the numbers were troubling. The discussions grew heated as papers and preprints flooded online forums. Some researchers built detailed models showing how unusual outgassing could, in theory, explain the acceleration. Others countered that the regular rhythm of the brightening cycles was too precise for any chaotic process. A few even brought up the light sail hypothesis, the idea of a thin, reflective structure designed to ride on starlight. This concept had once been confined to science fiction, but now it appeared in serious conversations among astronomers. No one could prove it, yet the possibility could no longer be ignored. Behind closed doors, NASA and the European Southern Observatory took a cautious approach. Officially, they repeated the line that more data is needed and warned against extraordinary claims without extraordinary evidence. But internal documents leaked to journalists revealed that 3I Atlas was classified as a high anomaly, a category normally reserved for potential threats. This label did not mean danger of impact, but acknowledged that the object defied existing models. The fact that it triggered James Webb's emergency override already showed how seriously the agencies were taking it. For the public, the split among scientists only deepened the mystery. On social media and in science magazines, arguments played out like courtroom battles, with each side presenting evidence and counter-evidence. The comet had become more than an astronomical curiosity. It was now a symbol of the limits of human knowledge. If even experts could not agree on whether it was natural or engineered, how could ordinary people decide what to believe? The debate leaves one pressing question hanging in the air. If 3I Atlas is not just a comet, but something more, then what risks could its strange tail pose to the fragile systems that orbit above our planet? While debates about the true nature of 3I Atlas raged among scientists, engineers, and defense analysts began to focus on a more immediate problem. The comet's long, ghostly tail was not only a symbol of mystery, it was also a potential hazard to modern technology. Observations showed that the coma was filled with carbon dioxide gas, nickel particles, and traces of toxic compounds like cyanide. For researchers, this raised an alarming possibility. If the tail drifted close enough to Earth's orbital highways, it could affect satellites that power the backbone of global communications. Modern civilization relies on more than 5,000 active satellites orbiting the planet. They manage everything from GPS signals and weather forecasts to military surveillance and banking transactions. Even small disruptions can have wide consequences. If clouds of metallic dust or chemically active gas from 3I Atlas were to spread into regions near satellite orbits, the results could be severe. Optical instruments might be clouded, lenses could be permanently damaged, and delicate detectors could lose calibration. A simple haze across a major space telescope could mean years of lost data, while interference with GPS would ripple through transportation and defense networks worldwide. The danger did not stop with optics. Plasma streams, especially those carrying metallic ions, can interact with satellite electronics. When charged particles collide with sensitive circuits, they can trigger false signals, short circuits, or even complete system failures. Engineers compared this to the effect of solar storms, which have previously knocked out power grids on Earth and damaged satellites. The difference is that solar storms are predictable events tied to solar activity, while the output from 3I Atlas appeared irregular and poorly understood. This unpredictability made the risk harder to calculate and therefore harder to prepare for. Some simulations suggested that if the comet's cyanide-rich gases dispersed widely, the contamination could extend thousands of miles. While Earth's atmosphere would shield people on the ground, satellites in orbit would have no such protection. Instruments designed to measure faint starlight could be overwhelmed by chemical haze, reducing their sensitivity. Even the smallest particles of nickel dust traveling at high speed could pierce surfaces or cause erosion over time. For agencies that depend on satellites for weather prediction, defense coordination, or international trade, this scenario was no longer just academic. NASA's Planetary Defense Coordination Office quietly flagged 3I Atlas as a high anomaly, not only because of its unexplained behavior, but also because of these practical risks. Reports warn that interference with satellite networks could have cascading effects across global systems. A single GPS failure could delay air travel, disrupt shipping lanes, or affect military readiness. In a world so dependent on orbital infrastructure, even one miscalculation could have real-world consequences far beyond astronomy. The question now extended beyond what 3I Atlas was to what it could do. If the tail of this strange visitor could threaten the systems that keep our world running, how prepared are we to defend against dangers arriving not from Earth, but from the stars themselves? 3I Atlas has broken every rule we thought we understood, from its strange chemistry and missing iron to its unnatural acceleration and rhythmic light. It could be a rare messenger shaped by unknown physics, or it might be the first trace of technology beyond Earth. What is certain is that this visitor has forced us to question our place in the universe and the safety of the systems we depend on. So, what do you think? Is 3I Atlas just a bizarre comet, or could it be a signal that we are not alone? Share your thoughts and follow MindGap for more secrets waiting to be uncovered.